Good morning, students. Welcome back to our session. Yesterday class we have learnt about light, wave nature of light. Light travels in the form of wave and it contains electric and magnetic waves, and these two waves are perpendicular to each other, and these two waves are traveling in the direction of in the direction of wave. And this wave has two important characteristics. What are that? Wavelength and frequency. So what is the relation between wavelength and frequency? What is that? C is equals to H mu. C is equals to H mu. By using this relation, you can find out the speed of light in a vacuum by the product of wavelength and lambda. This we'll learn. Today class, we are going to learn about what is spectrum, what is visible spectrum, and what is electromagnetic spectrum, and what is Max Planck's theory. This we'll discuss now today's video. Okay, let's start with what is spectrum. What is spectrum? See, from the sun we can get different kind of rays, but we cannot see all these rays. Only we can see a part of it. That part we'll call it as visible light. We'll call it as visible light. Visible light means it contains 7 colors, a group of 7 colors, Vibzier. And all these colors have different frequencies and different wavelengths. They have different frequencies and different wavelengths. So a group of wavelengths or a bunch of wavelengths is known as a spectrum. Once again I am repeating, what is spectrum? A group of wavelengths is known as spectrum, or otherwise you can call it as bunch of wavelengths is known as spectrum. So if you take Vibzier, it contains 7 different wavelengths. So it comes under visible spectrum, violet to red. Now, what is electromagnetic spectrum? What is electromagnetic spectrum? So electromagnetic spectrum means in this visible light, above and below also we have wide range of frequencies. The entire range of frequencies above visible light and below the visible light, all these frequencies are together are known as electromagnetic spectrum. Electromagnetic spectrum contains a wide range of frequencies. So here you see this is the different frequencies of electromagnetic wave. First, initially this electromagnetic wave has lower frequency. The wavelength, if you observe here, the wavelength is very less. If wavelength is less, okay, first we'll discuss about the wavelength. Initially the electromagnetic wave has less wavelength, then gradually the wavelength is increasing. Wavelength means the distance between any two peaks. The distance between any two peaks, that we can call it as, we have crest and trough. Upper part we can call it as crest and lower part we can call it as trough. Either you can take the distance between two crests or the distance between two troughs, or otherwise the distance between not any two successive peaks is known as wavelength. So here the wavelength is gradually increasing, and at end it has higher wavelength. The electromagnetic wave has higher wavelength. So initially it has lower wavelength, means its frequency is more. Why? Because frequency and wavelength are inversely proportional. If wavelength is less, the frequency is more. And the frequency and energy are directly proportional. If the frequency is more, then the particular range of wave has higher energy. In that particular range of wave has higher energy, means First, initially we have the cosmic rays. It has higher energy. Why it has higher energy? Because its frequency is more. Then after that we have gamma rays, then X-rays, ultraviolet rays. Then after ultraviolet rays we have only very less part. This will call it as visible light. It is visible light. Then after visible light we have infrared rays. Then after microwaves and radar waves, radio waves, broadcast band waves. So these are these electromagnetic wave has a wide variety of frequencies from cosmic rays to broadcast band waves. So the entire range of frequencies, cosmic rays has different frequency, gamma rays has different frequency, and each one has different frequencies. Due to that its energy is also different. First, it has wavelength is less. Due to that it has higher frequency. If it has higher frequency, that wave has higher energy. So cosmic rays are having higher energy, and this broadcast band waves has lower energy. And if you see this visible light, visible light means VIBGYOR. You can see VIBGYOR. So VIBGYOR above and below. Above we have ultra red rays, and below we have infrared rays. Ultraviolet rays, visible light, and infrared rays. So these ultraviolet rays are you can find in between X-rays and visible light. See this ultraviolet rays that you can find in the electromagnetic wave or electromagnetic spectrum in between X-rays and visible light. See this ultraviolet rays have higher energy than visible light. Why? Because its frequency is more than visible light. So due to that reason, its energy is more. So our Earth has covered by a layer of ozone. Due to that, it avoids to enter this ultraviolet rays to our Earth. Without entering, that ozone layer is protecting us. So nowadays, due to the harmful gas, due to the pollution of these gases, that ozone layer is depleted, and in some of the regions that ozone layer is depleted, and due to this reason the rays are entering to the earth atmosphere. Due to this reason, the persons we have facing the problems of skin allergies, cancer problem, etc. due to this ultraviolet rays. Now coming to the infrared rays. When you heat your body, it emits light. And light means first when you heat means it absorbs heat, and again it emits heat. So that when it is emitting heat, it emits in the form of light. So that all comes under infrared rays. So these infrared rays have lesser energy than visible light. Now, for example, this is about the electromagnetic wave or electromagnetic spectrum. So now we discussed what is spectrum, what is visible spectrum, and what is electromagnetic spectrum. So these three are important in 1 mark. So these definitions are important in for 1 mark. Now, one more activity. You take an iron rod, and that you have to heat it on flame. When you heat, then the iron rod, metal is a good absorber, good conductor of heat. Means it absorbs heat. When it absorbs heat, it emits light. When you heat a rod, metal rod, iron, suppose for example if you take iron rod, when you heat it, first it absorbs that heat and it re-emits that heat in the form of light. So first it emits red color. So if you keep on heating that metal rod continuously, then it emits different kinds of colors. red after yellow, orange, like orange, yellow, blue, like it emits different colors. Okay, but we cannot observe all these colors. When you heat a rod, it emits different kinds of colors, but we cannot observe all these colors. You can observe only the red color. Why? Because when you compare the intensity of all these colors, the intensity of the red color is more. The intensity of red color is more. Due to this reason, even if it emits different colors, we cannot observe because the intensity of the red color is more. Okay, now